Today we're going to talk about the quadratic formula, so the student will be able to apply their knowledge of simplifying square roots in order to use a quadratic formula to solve quadratic equations. Here's kind of the part that's new. The quadratic formula should be familiar for you. You should have used it before, but this part is different. So you now know how to simplify a lot of types of square roots. That's the part that we're going to add to this today. All right, so you're going to use the same quadratic formula you used before. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. It's really hard for me to just say that and not sing it because I was forced to sing it like Pop Goes the Weasel. So if you need something to help you remember it by, just YouTube quadratic formula, and there's tons of different songs you could use to remember it, okay? Now, where do those letters come from? The standard form of a quadratic equation, ax squared plus bx plus c. Now, we are using the quadratic formula to solve quadratic equations, all right? We now know multiple ways to solve quadratic equations, all right? The first way we know how to solve quadratic equations is we know we can solve by finding the zeros on the graph, right? Or the x-intercepts. Or we know we can solve by setting our factors equal to 0 and solving each of those. So we can solve by factoring. Or the last method we learned was we can solve by completing the square. So all three of those things are all just ways to solve a quadratic formula or a quadratic equation. If you have an x squared, you can't just get x by itself like you can for a linear. You have to use one of these methods. The fourth and final method we're going to learn is using the quadratic formula. So if I get my equation set equal to 0, then I can use the quadratic formula. So that's step one. Just like in factoring, step one, you need the equation to equal to 0. Okay, so don't forget about that. All right, so we are going to find the zeros or the x-intercepts or the solutions using the quadratic formula. So it could be asked that way, find the zeros. It could be asked, solve the equation. Or you could say, find the solution. All three of those instructions mean the same thing because remember the x-intercepts could be represented as zeros or roots or solutions, okay? All right, example number 1. First, we need it to equal 0, so we're going to turn y to 0. So when y is 0, that means we're on the x-axis. Y equals, so 5x squared minus 2x. Now, this is missing the c part, so we're going to add a plus 0. Because there is no c, so we use 0 to represent that. So in this equation here, my a value is 5, b is negative 2, and c is 0. All right, now to build the quadratic formula, negative b. Well, if b is already negative, then when I use the formula, it's going to become positive. Plus or minus. We use plus or minus because the answer to a square root question is always a positive or a negative. All right, square root. B squared, so negative 2 squared. You have to use parentheses for that, okay? Minus 4 times A times C all over 2A, okay? Now, we're going to simplify. So we have 2. Oh, first of all, this needs to be x equals because we are solving for x values, okay? So x equals 2 plus or minus the square root. Negative 2 squared is negative 2 times negative 2 is a positive 4. Minus 4 times 5 times 0 is 0. All over 10. Okay, so 2 plus or minus 4 minus 0 is 4. The square root of 4 is 2. All over 10. Okay, at this point, when there's no square root left, you're going to split this into two problems. 1, 2. Because there's two possible answers, one with a plus, one with a minus. So x equals to plus 2 over 10, which is equal to 4 over 10, which simplifies to 2 over 5. Or x equals to minus 2 over 10, which is 0 over 10, which is 0. So your two answers, the 2 points where this graph would cross the x-axis, is x equals 2/5 and x equals 0. Or we could write them as ordered pairs, where x is 2/5, y is 0, x is 0, y is 0. And y is 0 because you're on the x-axis, okay? There's our answer for number 1. Number 2, 0 equals 2x squared. Now this one is missing the middle piece. It's missing b because it doesn't have just an x. So we're going to say we have 0 x's minus 3. So a is 2, b is 0, c is negative 3. All right, so now x equals negative b. Well, negative 0 is still just 0, plus or minus the square root of b squared minus 4ac all over 2a. All right. 0 plus or minus the square root. 0 squared is 0. So 0 minus. So we have 0. Now we have negative 4 times 2 times negative 2. So negative 4 times 2 is negative 8 times negative 2 is positive 16. So this changes to a plus over 4. All right. So really we have 0 plus or minus the square root. 0 plus 16 is just 16, and the square root of 16 is 4. So I have x equals 0 plus or minus 4 over 4. So that's going to split into 2. So 0, let's rewrite that. X equals 0 plus 4 over 4 is 4 over 4, which is 1. Or 0 minus 4 over 4 is negative 4 over 4, negative 1. All right, so our answers are the x-intercepts, or the solutions, or the zeros, is where x equals positive 1 and x equals negative 1. So I could say it's the ordered pair 1, 0 and negative 1, 0. Because the y value is 0 because you're on the x-axis. All right, example 3. Example 3, this has all of our parts. So a equals negative 1, b equals negative 5, c equals negative 11. All right. X equals negative b. Remember, if b is already negative, it becomes a positive. So 5, I'm going to write this a little bigger. 5 plus or minus the square root of b, negative 5 squared, minus 4ac all over 2a. All right, so we've got x equals 5 plus or minus the square root. Negative 5 squared, negative 5 times negative 5 is positive 25. Negative 4 times negative 1 times negative 11 is negative 44. All over negative 2. So x equals 5 plus or minus the square root. 25 minus 44 is 11. No, it's not. Hang on. Negative 19. I was way off. all over negative 2. Okay, at this point, all of the square roots we've had before have been perfect squares. Square root 16 is 4. Square root 4 is 2. Square root 19 is not perfect. It doesn't have a perfect square in it, and we can't split it up. But we can split up the square root of negative 19. So at this point, I would go off to the side and simplify your square root. So square root negative 19 is the square root of negative 1 times the square root of 19. Square root negative 1 is I. Square root 19 does not simplify. It can't be broken up. So we're going to change this to that. So now I have x equals 5 plus or minus. Square root negative 19 is really I square roots of 19 over negative 2. All right, normally at that point I would split it up, but I'm not going to split it up this time because I can't do anything. I can't do 5 plus I square root 19. They're not like terms. I can't do anything with it. I can't do anything with 5 minus I square root 19 because they're not like terms again. So when you get to a point like that, you just represent both of your answers in one large, nasty looking situation. So this is representing both answers because it has the plus, the plus and the minus. We just can't go anywhere further with it, so we know that both our answers are represented that way, okay? All right, example 4. X equals 2, A. A is 2, B is negative 2, C is 3. So X equals negative B. I'm going to make it a positive 2. All of our B's here were negative. If B were positive, when you made negative B, it would be negative. But just be real careful there. B squared minus 4AC all over 2A. All right. 2 plus or minus the square root. Negative 2 squared is negative 2 times negative 2 is positive 4. Negative 4 times 2 times 3 is negative 24. All over 2 times 2 is 4. So x equals 2 plus or minus the square root. 4 minus 24 is negative 20. All over 4. Okay, at this point, go to the side. Simplify your square root. Let me make that a little bigger, sorry. Actually, I'm going to come down here because I have room. So the square root of negative 20 is equal to the square root of negative 1 times the square root of 20. Negative 1, I, but 20 can break down to 4 and 5. 4 is a perfect square. The square root of 4 is 2. So I have I and 2 square roots of 5. The proper way to write that would be the 2 first, and then the I, and then the square root of 5. All right, so we're going to put that into our problem. So I have x equals 2 plus or minus square root negative 20 becomes 2I square roots of 5 all over 4. Okay, now we're not going to split it up because I can't add 2 to 2I square root 5. They're not like terms. So we're going to leave this as a large fraction. But you do need to check you have 3 parts. So 2, 2, and 4. If all 3 of those numbers can be simplified, then you simplify it. If only 2 of them can be simplified, then you can't do anything with it. These 2, 2, and 4 are all divisible by 2. And when I divide by 2, I end up with a 1, and a 2. So you can simplify the fraction if all 3 numbers are able to be simplified. If only 2 of them can't, you can't do anything with it. So x equals 1 plus or minus 1I is just like saying I square root 5. So I don't have to write that 1 all over 2. Okay? Here we go. Okay, so both answers are represented there because of the plus and the minus. I'm not going to split it up because I don't have just whole numbers. So I don't have like terms and I can't add anything together. Your assignment today is matching. So I need you to, I need you to complete the assignment in Canvas and also send me an email picture of your work, okay? Because it's matching. So we kind of changed that rule. Other than that, you're good to go.